Hello pre-calc students. Today we are doing parametric equations guide notes. So I'll read our introduction. In the study of algebra, we look closely at relationships, how things are connected or related through similarities and differences. We have discussed functions and relations to find input and output values, but this is not the only way to look at some situations. For a real-world example, consider when a hurricane is heading towards the southern United States. The closer the storm approaches the coast, the more gas and bottled water is sold. Suppose for every 100 miles the storm moves, that a convenience store sells X gallons of gas and X squared bottles of water. Algebraically, that relationship would be written as follows. Bottles of water is equal to the gallons of gas squared. Even though this is correct, it is misleading. The equation implies that gas is changing the demand for bottled water, when really it is proximity of the storm in miles to a region that has changed both items. It would make better sense to write two separate equations where we considered either miles from the shore or time as the changing parameter. We could write two separate equations to model the situation. Gallons of gas is equal to miles minus 100, and bottled water is equal to miles minus 100 squared. In this way, you can see that miles from the shore is the cause for changes in the sale of gas and water due to the impending storm. Parametric equations help us look deeper at hidden parameters that affect change. So x is equal to our horizontal distance at time t, and y is equal to our vertical distance at time t. Four important facts. Parametric equations: x is equal to f of t, y is equal to g of t. Two, parametric equations involve three variables, x, y, and t. They allow you to look at a piece of the curve, and x, y describes the location of the object. So for parametric equations, time t, which is time, is the parameter. All right, clearing annotations and moving on. And also get some vocabulary there. Parameter is a third variable t used to represent time for a location of an object on a plane curve. In a plane curve, the set of ordered pairs x, y as a function of time that describes motion problems. So our steps to graph: select values for t over the given interval, find the ordered pairs corresponding to each value of t, plot the points, connect the points with a smooth curve, draw arrows to show the direction along the curve as time t increases. So let's look at x. X is equal to t minus 1. So when t is 0, plug 0 in for t, x is equal to 0 minus 1. So 0 minus 1 is negative 1. When t is 1, 1 minus 1 is 0. 2 minus 1 is 1. And 3 minus 1 is 2. Now y is equal to t squared minus 2. So when t is 0, y is equal to 0 squared minus 2, so negative 2. 1 squared minus 2 is 1 minus 2, which is negative 1. 2 squared minus 2 is going to be equal to 4 minus 2, which is going to be 2. And 3 squared minus 2 is going to be 9 minus 2, which is going to be equal to 7. All right, x, y, that's going to be equal to negative 1, negative 2, 0, negative 1, 1, 2, and 2, 7. So we're going to have the point negative 1, negative 2, 0, negative 1, 1, 2, and 2, 7. All right, so we're going to connect these points with a smooth curve. and we're going to draw arrows to indicate the direction of time. So these arrows indicate the direction of time. So this is graphing parametric equations. Eliminating the parameter. This allows you to find the equation that represents the curve. So we need to solve for one variable in terms of t. So in this, we're going to choose the x variable. So x is equal to t minus 1. If x is equal to t minus 1, then to solve in terms of t, we need to isolate t. So t is equal to x plus 1. X is equal to t minus 1. Add 1 to each side. T is equal to x plus 1. Additionally, t is equal to x plus 1. So now that we know t is equal to x plus 1, we need to substitute this into the other equation. So y is equal to t squared minus 2. We need to substitute t is equal to x plus 1 into the t squared minus 2 equation. So y is equal to x plus 1 squared minus 2. All right, so y is equal to x plus 1 squared minus 2. That means y is equal to we need to simplify here. And x plus 1 squared is going to be equal to x squared plus 2x plus 1. That's because, just a reminder, a plus b squared is going to be equal to a squared plus 2ab plus b squared. So here, a would be equal to x, b would be equal to 1. So you have x squared plus 2 times 1 times x plus 1 squared. And that's how you get that. But remember, you have that minus 2. Minus 2. So it's going to simplify to y is equal to x squared plus 2x minus 2. And let's bring out our trusty calculator and graph this equation to find out some information about it. Y is going to be equal to x squared plus 2x. Oh, I'm sorry. I messed up here. 1 minus 2 is going to be negative 1, not negative 2. Minus 1. And the reason why it's minus 1 is that 1 positive 1 minus 2 becomes negative 1. Okay? So my apologies. So that's x squared plus 2x minus 1. Graphing the equation, we have a parabola, right? Tracing on that parabola. I think it's pretty clear our center is at negative 1, 1. If we really want to find that, we can calculate that minimum value. Just to find this minimum value, do left bound and a right bound value. When we do our best guess, we find we have a minimum at negative 1, negative 2. So we have our minimum at negative 1, negative 2. Our x value is negative 1, our y value is negative 2. So looking at this parabola, remember our lowest value is negative 2, so our range is from negative 2 to infinity. Parabolas have a domain of all real numbers. All right, it increases. it's going to be increasing on this interval where the parabola has a positive slope. It's going to be increasing from -1 to infinity. It's going to be decreasing from -infinity to -1. That's when it increases. This is when it decreases. And now we're analyzing the function of real numbers, and we've done that. So graphing parametric equations. Graph on the plane curve from -2 to 2. So when t is equal to -2 to 2. All right. X is equal to t squared plus 1, y is equal to 3t. So when t is -2, -2 squared plus 1, -2 squared is 4, 4 plus 1 is 5, -1 squared is 1, 1 plus 1 is 2, 0 squared is 0 plus 1 is 1, 1 squared is 1 plus 1 is 2, and 2 squared is 4 plus 1 is 5. Y is equal to 3t, so 3 times -2 is -6, 3 times -1 is -3, 3 times 0 is 0, 3 times 1 is 3, 2 times 3 is 6. So xy is going to be 5, -6, 2, -3, 1, 0, 2, 3, and 5, 6. All right. So we will have 5, -6. So x is 5, y is -6. We'll have x is 2, y is -3. We'll have x is 1, y is 0. We'll have x is 2, y is 3. And we'll have x is 5, y is 6. And then what we do is we draw a smooth curve, and we draw arrows to show the direction of time. And so this is the parametric equation. So that's it for example 3. Let's move on. We need to eliminate the parameter and sketch the curve, okay? So we need to substitute and solve for y. So let's substitute and solve for y. So if x is equal to the square root of t, we can square both sides and know that x squared is equal to t. And if y...
A custodian to the main lobby in the front. Can I get a custodian to the main lobby?
And if y is equal to 2t minus 1, then that means y is equal to 2x squared minus 1. So y is equal to 2x squared minus 1. So we've substituted and we have solved for y, okay? So now we need to find the vertex here. And so let's we can find our vertex by factoring out 2, right? So think about it. We can actually factor out a 2 here and write y is equal to 2 factored out of times x squared minus 1/2. All right, so that's one way to put it. But if we really wanted to get into vertex form here, we could complete the square, because this is in the form negative b over 2a, okay? So this is a quadratic equation. That's one way to do it. And it's in the form, remember, quadratic equations form ax squared plus bx plus c. Here, a equals 2, b equals 0, and c equals negative 1. So here, our x value of the vertex is going to be b over 2, so it's going to be 0 over 2, so our vertex is going to be at 0. And you plug 0 in for x, and that's going to be, our y value is negative 1. So our vertex should be 0, negative 1. So actually, while this factoring out part is true, it's not the best to define the vertex. So vertex should be at 0, 1. Another way that we can practice is completing the square. So we can have y plus 1 is equal to 2x squared. So remember, this 2x squared plus 0x. Factor out the 2, so y plus 1 is equal to 2 times x squared plus 0x, and 0 divided by 2 is equal to 0. 0 squared is equal to 0. So we add 0 to each side. I know this is trivial, but I want to be completely methodical. If you already get this, you can skip over this part. So this will factor into x minus 0 squared. This will be y plus 1 is equal to x minus 0 squared. And so then, remember, or I guess there's a 2 here. So that means y is equal to 2 times x minus 0 squared plus 1. So you could complete the square, or you can just rewrite this x squared as x minus 0 squared. This can be rewritten as 2 times x minus 0 squared plus 1. But anyway, this gives us a vertex at 0, 1. So this last part, you can skip over it. Our vertex is at 0, 1. And we can just plot points. 2x squared minus 1. So 2 squared is 4 times 2 is 8 minus 1 is 7. We can have a point at 2, 7. 0 y is equal to 2x squared minus 1. So, sorry. So we have a vertex at 0, 1, not 1, 0. So a vertex at 0, 1. 1 is going to be 2, 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So we're going to have a vertex of 0, 1. We will have